All right, welcome back to the Creation Reformation YouTube channel. Maybe you know this, maybe you don't. My name is Jake Ramgren. I started the Creation Reformation website and YouTube channel with the intent of bringing the creation science movement to the New England area. So I'm trying to bring a little bit more attention to these matters and topics of origin. So lots of conversations like that happen on the channel. But my background is in zoology. That's where I got that's what I got my bachelor's degree in, and so a lot of the channel is also me going out and going on hikes in the woods and different nature encounters and just kind of talking about some things about wildlife and conservation and other things that I'm excited and passionate about that I think are all kind of entangled in the topic of biblical origins. So some of my stuff is just checking out some wildlife, checking out some salamanders and beavers and all sorts of other things. But really, the primary purpose of this channel is to really dive into topics on creation and evolution. I'm a young earth creationist. Ever since getting my bachelor's degree in zoology, I've dedicated a lot of time to researching and reading about evolution and other matters on how we got here and our origins on all things. I do believe that the Bible is inerrant and that the Genesis account is historical. And so I've been diving into that. I read for the New Creation blog, which I have links all over the place to go to the blog if you want to read some of my material on there. That's basically a website that presents scientific research done by creationists, and we write summaries of it and present it to a more general audience. As well as introducing new concepts. Not every article is a summary of some research paper, but it is kind of getting up to speed on the latest in creation research. So that's my background. I am from New England, grew up in New England, and so that's where I've focused a lot of my efforts. And that's where we're getting to the topic today, because my first thing that I did with this YouTube channel, was taking a couple days in Cape Cod. And it's kind of a dream trip that I had always wanted to do. Is on my bucket list. I'd been to Cape Cod many, many, many times, but basically every year of my life, actually, I've been to Cape Cod at least once. But I've always dreamed of being able to just go out there kind of by myself, honestly. No offense to my family who's gone with me on most of my trips to the Cape. But I've always had this dream of just exploring the coast, the Cape Cod National Seashore and other areas of the coast. And so this YouTube channel kind of originates there. That's kind of the origin story of this channel, which has really gotten off to a quicker start than I thought. We're right around 50 subscribers as I make this video, and the channel's just a couple weeks old. So that's kind of encouraging. I know a lot of connections in the creation movement have been kind of pointing people here. So I appreciate that. But basically, I'm out here at the Cape Cod National Seashore, and I'm just going from spot to spot, right? At just places that I know I've always wanted to visit. I have them all on Google Maps, just one after another. And as I'm going to these places, I just started noticing some interesting things. And I just decided kind of there, I'd been contemplating, I guess, putting together a channel, or really, it wasn't necessarily a YouTube channel. I just wanted to put resources out there that would kind of make people more interested in the New England area, and also with the topic of origins. Like those two things are just what I really wanted to do. I want to put out content somehow that related those two things, because there's a lot of, if you look at creation content right now, there's a ton of it on the Grand Canyon. There's a ton of it on Mount St. Helens up in the Northwest. There's bone beds, paleontological bone beds across the country that are really popular. But here in New England, we have lots of Jurassic period or Jurassic layer dinosaurs. We have we've got lots of local storms and disasters in New England that really show you kind of what catastrophes are like. And that's what creationists are always looking for, is to study what catastrophes are like now, so we can reason back to what the flood would have been like. So there's a lot of potential to bring creationism, be hands-on with creationism here in the New England region. And so as I was thinking about this, I'm going along the coast, and I just started noticing things and making observations that I think were really interesting. And I just started documenting them. And I documented them and putting them in videos. And I was thinking, maybe this could be something that I do, as I put out videos on the New England region that helps, that can kind of put things in perspective for people who want to know more about creation science. And so that's kind of the whole vision where all this came from. And the first time I did this, I was at Nauset Beach. I went out onto the beach, and there are all these cliffs, kind of like what you can see in this first picture of my slideshow here. And the cliffs looked a lot like that. And so I'd always wanted to see the Nauset cliffs. So it was really exciting. I know it's like I've been to Cape Cod every year, and it was it was like my first time really being at Nauset Beach and Coast Guard Beach in that like authentic New England coast right there. And I filmed this video about the erosion on the beach cliffs. And I filmed like maybe 12 takes because I'm really comfortable actually in front of an audience where I'm talking to people. Like public speaking, I've always loved doing, and I go to conferences and speak at conferences whenever I can, and hosted a conference here in New England. And so I always love the opportunity to get an audience together and then just get up there and talk about something that I'm really interested in and try and educate kind of an audience. But doing it for a video is a completely different ballgame. I'm talking to myself or talking to the camera. I have to imagine that there's an audience listening. I have to point a camera at something that I want to focus on, and it can't be too crazy. And so it was all very experimental to the point where the 12 takes I did of the cliffs, I watched them afterwards and they were all kind of terrible. So I never actually used that one. But as I went, I filmed other videos to the point where I put together a short, I think 5 or 6 video series on coastal erosion. And that was the first thing that I did for this YouTube video and for this YouTube channel. And the playlist of those videos are up on the channel now. The really only place you can find them all together is if you click on playlists, because some of them are YouTube shorts and some of them are full-length videos. And so, but they're all pretty short. So you can get through all of them in under 20 minutes. They're not long videos. But basically then what happened is all trial and error here, this YouTube channel. It's all trial and error. So I published these 5 videos, and part 1, part 2, part 3, part 4, part 5. I did 2 at Nauset Lighthouse. I did a couple at Monomoy Wildlife Refuge, which I'll get to more later. But basically I put out these 5 videos, and whatever the YouTube algorithm did, YouTube, I don't know if it is YouTube's fault or what it really, I don't understand the algorithm, but part 3 of my series got the most views in the first week, like 350 views in the first week. Part 3. And part 3 of the series is like a 1-minute video that I kind of just impulse took because I was putting together the series in my head. I was like, oh, I can do a series on coastal erosion. And then I was also at a place that I always wanted to visit. That was where the outermost house was, which was a house built by Henry Beston that was out on Nauset Beach on the Cape Cod National Seashore. And he built this house and wrote a whole book about it. And I read the book because I love Cape Cod and really always wanted to go and visit that spot. And the house isn't there anymore. But basically I got to that point and I read about how the house was moved back multiple times because of coastal erosion. And then it was destroyed in a coastal storm. And I thought, okay, that's a quick 1-minute video. Cool. And it was supposed to be kind of part of the series. So if you'd watched the first 2 videos in the series, you would kind of understand the argument. So part 3, I kind of did out of context. So I was just like, here's the house and it's moving further inland because of coastal erosion. And of course, that's the one that gets the most views. So people were seeing it kind of out of context, didn't understand the whole argument. And that's the one video I think where I've gotten the most kind of long string of angry YouTube commenters kind of coming in and saying, you don't know what you're talking about. Like, that's the stupidest thing I've ever heard. And so like fair, I don't really blame them. And I'm always welcome for criticism and like come and watch my videos. If you want to leave an angry comment, like all the better, as long as you're kind of watching the videos and you know, that I appreciate that. So I wasn't disturbed by the comments, but I was a little bit kind of irked by the fact that YouTube just took part 3 of my series and showed that to way more people than the other ones. So it was definitely meant to be more in a series. And I kind of understand now that just because you say part 3 doesn't mean that people who watch your videos are going to watch part 1, 2, 3, 4, and 5. So that was something to learn from. But let's dive into this. So what I wanted to do with this video is I'm diving into what the actual argument that I'm making when I make a series about coastal erosion. So part of this is going to be personal story. It's kind of talk about my trip through the coast, and then it's going to kind of switch gears because I am not a geologist and I couldn't dive in and do all the research on this trip. So I went on this trip. I documented a lot of evidence, basically, or just observations, and I had a pretty good case in my mind, but then I had to do more research on the area. So let's dive into how coastal erosion shows that the North American continent is not actually hundreds of millions of years old. And so again, there's a lot of people who can come in and be like, this is the stupidest thing I've ever heard. And that's fine. But if you don't watch this whole video, you're not actually going to see the whole argument. And so this is the one to watch if you want to make this argument. If you ever have discourse, you're trying to convince somebody about maybe the age of the earth. This is a great, I think, line of argument to make. There's a lot of bad arguments in creationism. I think this one is a good one. So Basically, East Coast erosion challenges the idea of deep time. Deep time is the concept that the world is millions to billions of years old. And I think that there's processes going on in North America related to East Coast erosion that challenges the idea that this continent could have been around for hundreds of millions of years. So let's get into this. Here is a snapshot from the first video, the very first YouTube video I ever filmed that I did not end up using because it was windy and I wasn't good at this. And I'm still not really great at this. But, I'm sorry. Basically, this is what Nauset Beach looks like. If you just go straight to where everybody starts in Nauset Beach, you read about, everything from the signs because it's a national park kind of. And then you walk down the stairs, you get to the beach, and there are these cliffs. And so what you can notice is obviously there's erosion happening here. This is like textbook erosion. I'm not a geologist, but I can tell that the ocean is moving onto the beach and removing sediment from the beaches, and these cliffs are going to shrink over time, right? The sediment and the grass and everything that is on this cliff is being cut away and removed by the Atlantic Ocean. And what's fascinating is that if you go to Nauset Beach and you look at some of the information that they give you at the beach, they will tell you how quick the erosion is. And what it says at the place, again, not me saying this, I didn't do any calculations on this. This is what the national parks tells you when you're at Nauset Beach. They say that the erosion is about 3 feet per year. Now, that is ridiculously fast for a geological process, 3 feet per year. So it's very natural for me as a creationist to start to reason back and think, how doesn't that put a date, an expiration date on the continent? If it's moving at 3 feet per year, how long would it take to really wipe out all of North America? And that kind of puts like I said, an expiration date on how old North America can be. So there's a picture of that. That's what the beaches look like. You can always look them up on Google, and you're going to see lots of pictures of the cliffs along the East Coast. And there's a lot more that goes into this, but this is kind of the first point in the argument is if erosion is 3 feet per year, doesn't that put an expiration date on how old the continent can be? And so my next video, I went up to Nauset Lighthouse and I filmed the lighthouse and talked a little bit about that. And that I actually did use, so you can find that video on the channel. And I also caught a little bit of the information board that is there at Nauset, and it shows you where the lighthouse used to be. The lighthouse, Nauset Lighthouse, is actually evidence of coastal erosion being too rapid because it continually has to be moved back away from the ocean. So obviously a lighthouse has to be close to the ocean because it has to be seen by ships passing through. That's the purpose of a lighthouse. And so you can't move it inland too far, but every time they move it back a few hundred feet, in a few years, it usually takes a few decades, right? They're smart enough. They put it back and they put it in a place where it can be for a little while. And after a few decades, the ocean cuts away at the cliffs and forces that lighthouse to be moved back again. And so, again, some of the comments on my YouTube video were saying, maybe, yeah, obviously the ocean takes away sand, but it's not moving the coast. Well, it kind of is moving the coast. It's not the North American continent, the plate that the continent is on top of, and we'll talk about this later. But like, sure, the continent itself isn't being cut away, but the coast, you have to argue, is, because you can only, like, one day you can walk out a certain distance towards the Atlantic Ocean, and then a year later you can't walk out as far. It's been reduced by 3 feet about. And so this is, again, really rapid geological processes happening here that are too fast to explain in an old timeline. Okay, and so that was kind of Nauset. I went to Nauset Beach, Coast Guard Beach. They both have these cliffs. They both have lighthouses, and the lighthouse, it continuously has to be moved back. It's moved back, I think, 4 times, and the 4th time they waited until the ocean was only 40 feet away. So the ocean just catches right up to it, and they have to move the lighthouse back. And this is common of lighthouses throughout New England. There's lighthouses in Maine that have to be moved back all the time. And you just look it up. Lighthouses, there's a company actually in the Northeast that specializes in putting a platform under a lighthouse, picking it up and moving it back quite a bit. So the next, I kind of moved on to probably one of the most beautiful places I've ever been to in my life, which is Monomoy Wildlife Refuge. And I spent pretty much a whole afternoon here. It was sensational. It's like you would have no idea. People think of New England as like cold and rough and rugged and not exactly tropical. And while that's true, and we take pride in that, right? New Englanders love that about New England. It's one of the reasons why we like it. There is a place, if you go to it in the right time of year, and I went like early September, so it was right after peak season for summer, so there's not a ton of people around, but the weather was still gorgeous. And so I went out onto Monomoy, and it's like the elbow of the Cape. And people talk about Cape Cod like it's an arm, and then you can actually like designate where places are on the arm of Cape Cod. And this is on the like the tip of the elbow is Monomoy Wildlife Refuge, and it's got an island, and that's where often the great white sharks are often seen around that island. If it's not like a fisherman recording a great white shark, and if it's just somebody who's noticed a great white shark, it's usually on that excursion around Monomoy Island, because there's a lot of sharks around there, and it's a chance for you have a lot of people watching the ocean on a boat going around Monomoy Island. So it's gorgeous. It's beautiful. It was really a paradise is the word that kept coming to mind for me. It was a beautiful walk. So I'm walking all along here, spending a whole afternoon here. I wanted to take the tour around the island, but there was rough seas, and so they had to cancel. But anyway, I was really just exploring the whole coastline, and I ran across a spot where there's basically a patch of woods on Monomoy that ends right as a beach. So it's a forest, it's all trees, and then you walk there, and the leaves on the ground turn into sand, and you keep walking, and you basically hit the water, and it's like the forest just ends. And then the trees here you can see the erosion in real time happening with the trees, because the ocean is coming in, removing all the silt and sand and sediment, and leaving behind the mangled tree roots of these dead trees. And that was really, really fascinating. So I took a few videos there. One of them is posted on the channel. You can see a video of me walking around pointing my crappy phone at all of these dying trees. And it's like, look at that. Like, you can see it in the picture that it's very obvious the ocean is taking away sediment and leaving tree roots there in these dead tree formations. And what I even noticed is if I walked along the coast in the direction that my camera is pointing at in that picture, I would find just the bottoms of the trees where the trunk is kind of rotted away and like taken away, but the tree root system is still intact, and it was taken by the ocean and then dropped off on the beach further down the coast. So other trees have obviously been taken away before, and these trees I see in the picture are not too far behind. So this again shows you in real time what happens, and no one's moving these trees back because no one needs the trees there, right? We move the lighthouses back, but the trees here, nobody's moving them back. So the trees are going to get wiped out by the ocean, and this erosion is just going to keep coming. And again, really rapid rates, 3 feet per year. It's probably not, that's what it was with the Nauset Cliffs. It's probably not that different here at Monomoy. This is just a few miles south of Nauset Beach. So really beautiful location. Highly recommend going to Monomoy Wildlife Refuge. And you can check out some of this evidence for yourself that erosion is happening really, really quickly, taking away sediment and leaving behind these trees with this mangled roots left behind with no sediment to live on. So, and the sand that you can see in the picture, it goes back maybe a few more feet, and then it turns into leaves, and it's just like a normal woods, like a normal New England woods. And so you can walk through the woods and not even realize that the woods is about to end, and then suddenly it's the ocean. So that was really cool. And that's just me exploring Monomoy and like finding evidence of rapid erosion. Here is another one that is very obviously dying because the ocean is just taking away all of the sand. And then that tree is going to be sucked out into the ocean. Eventually the whole tree is going to be removed because all of that sand that the tree is in is also going to be removed and pulled back into the ocean. And then that tree root system is going to be dumped further down the coast eventually. And that tree is now history. Okay, so now we come to the actual question, which I haven't yet asked, but have been kind of moving towards, which is erosion really too fast? And I made a horrible typo there. That should have 2 O's. Is erosion too fast for deep time? The rate of erosion is about 3 feet per year in the northeast coast. The width, this is what I did. I just did some simple math here. The width of North America continent, based on a quick Google search, North America continent is about 2,800 miles from coast to coast. And the age of North America in the conventional timeline since it broke away from the supercontinent called Pangaea, that was 200 million years ago. So 200 million years, North America is moving away from the other continents. It is today 2,800 miles from coast to coast, and the rate of erosion has been 3 feet per year. Now, let's just say, again, because allegedly erosion's been happening this whole time as the continent's been moving away from Pangaea. So if we do some simple math, though, starting today, how long would it take for the entire North American continent to be eroded away? If we started measuring it today, 3 feet per year, 2,800 miles, how long would it take erosion to wipe away the whole thing? So 2,800 miles, well, you have to convert that to feet, or you can convert 3 feet per year into miles, but that seems more complicated. So let's take 2,800 miles, multiply that by 5,280, and you get 14,784,000 feet. That's from west coast to east coast of North America. Now, at 3 feet per year, you basically divide that by 3, and you get the expiration date for how long we have in North America to stand on. 14,784,000 feet divided by 3 feet is 4.9 million. That's how many years it would take to wipe out this entire North American continent. We are basically standing on land that will not be here, almost guaranteed in 5 million years, unless something dramatically changes. It would take 5 million years to erode away all of North America if it started today. And that puts a timestamp on how long we have a continent to stand on. Now, that does not mean that the continent should be gone now, because erosion's been happening up until this point. So from 200 million years ago to today, erosion's been happening. But from today, it would take 5 million years for our continent to be eroded away entirely. So the question is, where did the erosion begin? Was North America originally several times larger than it is today? That seems pretty ridiculous, but we can kind of explore that. So those are relevant questions. We know for a fact that at today's current rates, assuming nothing dramatic changes, at today's rates, it would take 5 million years only to wipe out all of North America. And North America has existed, allegedly, for 200 million years. So that's enough time to erode this continent many, many, many times over. So where did the erosion begin? That's a big question to ask. Does the rate of erosion change? Is another good question to ask. And then finally, this is the most important one for conventional thinkers who accept the old Earth timeline. Are there processes that can offset or slow down or cancel out the erosion? Those are our 3 relevant questions. And so this is when I had to do research. So I've gathered my data, I've filmed lots of videos, taken pictures, and noticed that erosion is happening really quickly. Now I ask my questions. Is this a problem for the deep time model? And what are the answers to these questions? That's where I have to do research. And for the research, I something sparked my mind when I was going and making these videos. And I had this memory of a podcast that I listened to by Todd Wood and Paul Garner called the Let's Talk Creation podcast, which I do go back and visit quite a bit. And I remembered an episode that I'd been excited about listening to because they were talking about Cape Cod in the Northeast and some erosion. And so I was like, where was that episode? So I looked up that episode and found their guest on that episode was Monty Fleming. And Monty Fleming is a geologist who wrote a book about why he is not, why he is an Earth creationist and why he does not believe that the continent of North America, or really the whole world, is millions and millions of years old. And so Monty Fleming basically has done all of this research already. So I'd collected a lot of videos and information, and then I found Monty Fleming, and really he dove into this much more in depth than I ever could, being a zoologist. So I'm using a lot of his material for basically the second half of this seminar. So basically, Monty Fleming points out kind of all these things that I'm going to be showing you. Which the first question he has answered very well. How do we know where erosion began? Can we look out into the ocean and find a spot where erosion must have begun? And in fact, we actually can. These are pictures from Google Earth, and you can. What's funny is that when we go out to Cape Cod and you see this erosion moving in, when we go out and we go swimming in the ocean, right, on vacation, and I go to Nauset Beach, for example, and I start swimming in Nauset Beach. When I step into the water, I'm not leaving the continent of North America. right? It's not like the continent ends and the ocean begins. It's not even that land ends and ocean begins. When I walk out into the water, I'm still standing in North America. I'm still standing on Massachusetts land. And the land actually continues out quite a bit. And so when you look at Google Earth, you can actually see where the continent itself ends. So those are some pictures on both coasts I have. And if you look at the one on the East Coast, you can see there's a couple of there's a light blue color and there's a dark blue color. And the light blue color starts where the coast is and moves all the way out until a certain point, and then it stops. And I try to make it three-dimensional there from Google Earth images, and you can see it's like a cliff. And that's what we call the continental shelf. And that is really where the continent began. And erosion has basically wiped away the coastline and the beaches up until the point where it is today. So we can reasonably assume that that is where coastal erosion began, wiping away the continent. And so that kind of puts a timestamp on how long erosion has been going on. And I don't think I have it on the slideshow, but Monty Fleming did calculate like how long has erosion been happening according to this idea. If we reason backwards and you start adding sediment onto the continent at 3 feet per year about, and you go all the way back to where it matches where the continental shelf is, how old is the continent? And I believe he said in the hundreds of thousands of years range. So a couple 100,000 years, which is way longer than young Earth creationists believe it would be. But it's way, way, way shorter than, way more less time than conventional scientists have to work with. They need the continent to be 200 million years old. And what it looks like now is it looks like it's 200,000 years old. Okay. So what it looks like is not what it is, but it looks like it's 200,000 years old. They need it to be 200 million years old. We need it to be in the 4,000 year range, because that's when the flood happened, and everything since the flood has basically been processes leading up to today. Now, 200,000 years is not the death knell of young Earth creationism. We don't just say, all right, well, the continent is 200,000 years old. In the creationist timeline, we have rapid geological processes happening. So the erosion probably sped up in the past with the flood, as we believe that the continents were sprinting away from each other in the catastrophic plate tectonic model. And so as continents are spreading away from each other much faster than conventional geologists believe, then erosion could also have happened much faster than the geologists believe it could. So we still, as creationists, we continuously have to accept that there were processes happening much faster than they are today. Today's process is too slow to account for that much erosion in 4,000 years. But we have the mechanism to do that. We have a worldwide flood. We have dramatic catastrophic processes happening at the flood and then happening between the flood and today that could have sped up erosion. So the continents are sprinting away from each other, and because the oceans are moving back into place after the flood, all sorts of processes are happening that could result in the kind of formations that we see today. So rapid geological processes happen to get to where it is today. Now, the conventional geologists do not have rapid geological processes. They basically believe that at whatever rate it is today, we should assume it's been at that rate for all of its history, unless we have evidence of some other rapid catastrophe that they can point to. So we have about 200,000 years of erosion. I believe that's what Monty Fleming said. I wouldn't necessarily quote me on that, but you can find he has a seminar on it on YouTube. And he also has the podcast with Todd Wood and Paul Garner. I almost combined their names. So I can link both of those for you to check out if you're interested in more of this. But basically, you have 200,000 years of erosion evidence now. Way too short of a time to explain if you're in old Earth, and somewhat reasonable, actually, if you're a young Earth creationist, because you believe geological processes can speed up and do that and give you that erosion in a short period of time. So the light blue is the continental shelf. The continental shelf shows you where the continent ends. When the continent ends, it's just basically a stop and then a steep dive down to the deep sea. And I also show you the West Coast picture to show you that West Coast erosion is actually much slower than the East Coast. The East Coast actually has harsher, the ocean is harsher here, and it takes away more sediment every year. So it's a much faster erosion rate in the East than it is in the West. So for both of these, it's showing about 200,000 years worth of erosion. But because the erosion rate is slower on the West Coast, that's why there's less of a continental shelf on the west coast. Hopefully that all made sense. So we can tell where erosion began simply by looking at Google Earth. That's basically the best explanation for that. Now, does the rate of erosion change? And here I have just a couple of pictures of Cape Cod news. You can look up. There's plenty of Cape Cod news articles talking about erosion. And actually, my first time hearing about erosion is I bought a book in Cape Cod. It's all about the region of Cape Cod as a kid, and I was reading it, and I really like Cape Cod. Okay, and I was reading this book, and it opens in the introduction. It says that Cape Cod is not going to be around for very long. And I remember being like frustrated and upset that they said that, because as a kid, it's like, think of your favorite vacation spot as a kid, and then imagine someone coming up and telling you that like the ocean is going to wipe it out and you're not going to be able to go there anymore. So it was kind of heartbreaking. So basically all I'm saying is you can look up anything from Cape Cod and they'll tell you there's lots of erosion happening. Now, there are processes that can change the rate of erosion. There are storms, basically. And we are very famous for our nor'easter storms, okay? The nor'easterns that hit us, they're basically like hurricanes that are cold and are in the northeastern direction. They hit us from the ocean, and they can basically increase the rate of erosion. And so you can see basically these houses like this one that are being built that are going to get knocked over because erosion is happening so quickly. But all throughout Cape Cod, it says this: oceans might swallow Cape Cod sooner than you think. 12 images before and after a storm at Duck Harbor Beach in Wellfleet. So a storm hit, and there's all these pictures afterwards of the rapid erosion that happened because of that storm. So storms can increase the rate of erosion. But as true as that is, those storms are kind of being incorporated into the 3 feet per year number that we get there. Because when it says 3 feet per year of erosion, that does not necessarily mean that every single year the coast has moved in 3 feet. Basically, 3 feet is an average. It's a mean. And you can put this on a bell-shaped curve, which is something scientists like to do. We graph things on a bell-shaped curve. And in the middle of the bell-shaped curve, again, it's basically like the middle is the average. And most things that you're graphing are going to be close to the average. And then the farther you get away from both averages, the farther away you get from the average in the middle, the less examples you have each one. So if we did like height in adult males in the US, the middle, the average height is, I believe, 5'9", which is my exact height. So 5'9" would be in the middle. There's a lot of people who are around 5'9", and then as you move in both directions, you move to the right. There's gonna be taller and taller and taller people. There are less people who have that height, and so the curve goes down to the point where you get to like the NBA's 7-footers who are at the very, very, very tip of the extreme on that end, and then on the other end, you get to the very, very, very short people. There are not nearly as many really short people and not nearly as many really tall people as there are people in the middle. So that's what the bell-shaped curve means. And so you can graph erosion by year in Cape Cod, Mass. this way. It's average 3 feet, but if a storm comes in, it could be 4 feet. I don't know how much a storm increases erosion, but let's say it does. Let's say a storm comes in, you get 4 feet of erosion in that year instead of 3. But then the next year there aren't any storms, and maybe the winds aren't so bad, and there's cycles in the climate and cycles in the weather, and you only get like 1.5 feet of erosion the next year. But then the year after that, you get 3.5 feet. And then maybe for a few years, you get 3.5 feet roughly, and it's like really, really quick erosion. And then you get a couple of years where there's not really many storms, there's not a lot of wind, there's not as much activity, and you only get maybe 1 foot. So erosion by year in Cape Cod can basically be graphed that way. 3 feet per year, I think, is a pretty steady number you can land on. And I know that they count storms in that calculation, basically because how could you not? Like, they're giving you this data when you're at the beach, and they're saying 3 feet per year. They're taking into account that there's a lot of things that happen on the Northeast coast every year. Sometimes there are fierce storms, and sometimes there are not. So 3 feet per year is still pretty consistent. I think you can argue that there's not going to be a lot of processes that increase it or decrease it for a long period of time. It's going to still average 3 feet per year. So yes, are there processes that can speed up erosion? Yes, but are they enough to explain how you have this much erosion in a short period of time? No. Are they enough to explain from the old Earth perspective how this much erosion has happened in, the millions of years they're talking about. No, like there's no processes that we can think of that would slow down erosion or speed up erosion as much as needed to by either creationist or evolutionist standards. I think 3 feet per year has to be relied upon as a good number. So just to get those, now I'm glad I got those out of the way. Hopefully got them out of the way quickly, because we have to move on to, are there processes that offset erosion? And this is where Monty Fleming comes in big time. So the bell-shaped curve, the Google Maps images, those are all kind of me. But this is where Monty Fleming's work really comes in the second half, because he has looked further than what most creationists would do. Most creationists would say, oh, this is 3 feet per year. That couldn't happen in millions of years. Case closed. It's over. The Earth is young. But Monty Fleming actually gave a benefit of the doubt to the old Earth story. And he said, I'm actually going to see what their explanations are for this and see if they hold up. And at first glance, it does seem like they hold up. There are a couple processes that could offset erosion over the course of millions and millions of years. The first process is called deposition or accretion. Accretion should probably be the word I use there. I thought I edited that. I thought I put accretion there. I'm not actually exactly, again, I'm not a geologist. They sound very similar processes to me, deposition and accretion. But he uses the word accretion, so I should have used that word. But basically, accretion, or the second process, is continental uplift, which is so accretion being sediment is being added onto continents rather than taken away, which does happen. Sometimes sediment is put on the continent instead of removed. And the second process is continental uplift, which is if you have erosion coming in and wiping out a continent, well, then the continent shifts and raises itself. That's going to push the coast even farther back. So I'll show descriptions of that are better than my awkward hand motions here in a second. But those are the two processes that have been proposed that can explain why we still have a North American continent to stand on given deep time. So process one, there we go. I edited it there. Accretion. If you're a geologist and you know the difference between deposition and accretion, then let me know. But I'm going to use the word accretion because I know that's the one that Monty Fleming uses, and he's the expert. So accretion is the first process. And what we use here is basically this paper that, do I have a reference in here? These slides did not come out right for StreamYard. I apologize for that. But basically, I will have the paper in the description for this video. But basically, it's a paper called "The State of the World's Sandy Beaches," and it evaluated where across the coast is there where is there accretion, where is there erosion, and where is there stable conditions where there's no accretion or erosion. So some places in the world there is more sediment being added, and in some places in the world sediment is being removed. And this is an evaluation of all of that. And it can all be summarized in this map that Monty Fleming also uses in his work. So basically, there's the map, and every sandy beach on the coast has a color. And if the color is red, that's where erosion is happening. So sediment is being removed. And if it's green, that's where accretion is happening and sediment is being added. And I know it looks like the Northeast has a lot of accretion. There is red mixed in there. So there's actually, obviously, I've shown you all the news clips about erosion in Cape Cod and why it's such a big deal. So Northeast is definitely eroding more than accretion is happening. But for this map, the way that they depicted it, there is some accretion happening as well. And so it's kind of a greenish reddish blob there. That is the both. And there is some accretion happening in Massachusetts. Basically, though, what the paper found is that 28% of the beaches across the world are experiencing accretion. They're gaining sediment. 24% of the sandy beaches are eroding. And so there's actually more accretion happening than eroding. And 48% of beaches are stable. There's no accretion, no erosion happening. They're just consistent. So if there's more accretion happening than there is erosion, maybe this explains the problem away, because sediment that is removed in one place is then there's sediment added in another place, and you can still have a continent to live on. So all these continents, if there's roughly equal and even more accretion happening, then the sediment is just being reshuffled. It's being moved from one place to another. It's not actually being removed from the continent and decreasing the continent. It's all just moving around. So is this a good response to the claim that that erosion is a big problem for deep time. I would argue not, and Monty Fleming would argue not quite. That's not quite the answer. Because again, I'm so sorry about these slides. I should have checked and make sure they're all good before I attach them to StreamYard. I guess I'll have to check on that next time. But you can still see, you can still understand the key and what's happening there. Basically, if you look at it, it's not a stable cycle. Sediment is being removed in one place and it's being added in another place, but it's not in a cyclical way. And what I mean by that is lots of the accretion is happening by either anthropogenically or by river deltas. And I'll explain what both of those are. This is what Monty Fleming found when he really dove into the study and looked at the data for himself. The study is showing you a map and it's calculating total accretion and total erosion. But there's a lot of things that come up in the total accretion number that really don't help the accretion numbers. For example, anthropogenic means human caused. That big green blob, I'll go back to this one where I don't have markings over it. That big green blob that's in the China and the east, right, between Japan and China, all of that land is accreting really quickly. There's a ton of accretion happening over there, but it's anthropogenic. It's human caused. Humans living there are causing more and more. They're causing the continent to kind of expand, and I'm not really sure how they're doing this. I don't know if like they're moving sediment around, they're dumping things. I don't know. I don't really know how they're doing it, but it's human caused accretion. And I do know, like, for example, Boston has a lot of human caused accretion as well. So I'd imagine it's something like what happened in Boston. So most of Boston today did not exist when Boston was founded, because what the history of Boston is, my students remember this because we took a tour of Boston and they talked about this on the tour. Basically, the Boston Harbor, you would basically have, this is the harbor, you would have, they would build docks and jetties out from the harbor that just kind of stick out from the harbor. So harbors here, and they would build multiple docks. I'm not sure that's the right word, but to dock their boats at, they would build these long docks, and then eventually they would collect a bunch of dirt from the land, and they would dump it and fill in the gaps between those structures and basically expand Boston out into the ocean. So that would kind of, on this map, that would come up as accretion, that people are dumping lots and lots of dirt into the ocean, filling in gaps between the jetties or docks, and fill it in, and they would expand Boston out towards the ocean. So that's happened in Boston, and that would come up here as accretion because more sediment is being added to the coast. Not that Boston is a sandy beach, but if they incorporated that into their study, that would come up as accretion. That's what's happening on the western coast or the eastern coast of China. It's human caused accretion. So that does not help you when you're looking long term at how is erosion offset over the course of hundreds of millions of years. Humans have not been there for that long of a time in geological terms. So that accretion that is being counted here shouldn't really count. So you can take that big green blob in the Eastern Asia and basically take that out and say that doesn't really count. That's human caused. That doesn't explain why we have continents because of the erosion. So that's not an answer. But also you have river deltas. River deltas throughout the world, a delta is basically a place where a river dumps into the ocean. And what happens is these rivers are picking up sediment, and then when they empty into the ocean, they're dumping sediment there. So this should account for the accretion. Yes, that is accretion, but that's not sediment being repositioned that's being taken away by the ocean. That's sediment coming from inland that is being dumped in one particular place along the coasts. And so that's not a stable cycle. If we took this and let's say, remember I made the whole calculation about 5 million years North America would be eroded away. This accretion doesn't really solve that, because if you play that out, those 5 million years, erosion continues to cut away. And all that happens is that the river deltas get more sediment. And so the accretion is happening in localized places, whereas the erosion just continues to happen throughout the coasts. I mean, look at Western North America there. It's all red. Eastern North America is mostly red, minus the river deltas. all of that red is going to be erosion, 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 erosion. And all that you're adding, all that's offsetting it is sediment and river deltas that are being dumped into the ocean in these little localized spots. So it's not a stable cycle. Okay. Yes, there's more accretion happening than erosion total, but because so much of it is anthropogenic and happening at river deltas, it's not stable. If you played this out over the course of millions of years, erosion would still eat away at all the continents, and we still have a big problem. It's not going to help Cape Cod that there's a river delta that adds a little bit of sediment in one place over time. Cape Cod is still not, it's still going to get eroded away, sadly. We still have a few thousand years before Cape Cod would be gone. So I get to experience it for the rest of my life. And that's good enough for me. Okay, so yeah, so it's exactly what I'm saying. It's unstable over time. Anthropogenic accretion cannot explain millions of years of sediment redistribution, and erosion on beaches and accretion in river deltas is not a stable system. So if all coastal beaches are eroding and then river deltas are experiencing accretion, that's not a stable system. The beaches are going to continue to erode. The river deltas are going to continue to gain sediment, and that's the end of the story. So that kind of blows out of the water the explanation that accretion and erosion form a stable system of sediment redistribution. It's not the case. It's not stable at all, and it's not enough to explain millions of years of erosion. So we move on to the second and much more compelling explanation for the old Earth geologist, which is continental uplift. So this is a paper, I don't know if Monty Fleming has used this, but I did a little bit of research on this and found this paper that has a couple of really good pictures of what's happening here. Not the one on the right, but the one on the left is from this paper that I have cited there from 2018. And basically, look at where the shelf break is in that first picture on top. You have the ocean, and it goes right up to the coast, and it stops right there, and there's a shelf break. Well, if the continent rose, okay, and all that lifted up, the shelf break that's labeled there would be moved back significantly, and the coast, the ocean would be pushed back. So just compare these two pictures. One of them has the water moving all up to the shelf break. Look at the bottom one. The ocean moves all the way up to the shelf break. Well, if the continent lifted up, that would push the coast back to the shelf break on the top picture. So, and the distance from the trench is key here. So if you see the distance from the trench is labeled at the bottom. So you have the continent, the continent goes and then it stops. All right. And then the water goes and it goes right up to the continent and stops right there. Well, if the continent lifted up, it would actually, and so this is where the shelf break is. The shelf break is moved back. The continent below rises up and it pushes the water further back. I'm really bad with hand motions demonstrating it, but you can see it from the pictures there. And so what that results in is a formation that looks like on the right, something called marine terraces, which is basically if this happened in a cycle, you would have erosion cuts away, then the continent lifts up, pushes the ocean back, and then the ocean erodes away again, pushes, and then the continent rises up again, pushes the coast back, and it all starts over again. And that's what results in something called marine terraces, which are on the right, which is erosion, uplift, erosion, uplift, erosion, uplift over and over and over again. And this actually is a cycle. This is a cycle that we were missing from the accretion explanation. Accretion and erosion are not forming a cycle that can last millions of years. This one might be able to because of uplift and pushing the coast back. And I have an explanation. There you go. So erosion pushes everything back, the continent uplifts, and then the coast moves back again. I should have put this up sooner instead of doing my goofy hand motions. But that's basically the explanation here. And that can explain a lot of the erosion. Like as a creationist, I hate to tell you, that explains how millions of years of erosion could happen. And we still have a continent today. So, and Monty says this in the podcast, which basically is like, do we just give up now? Like, is that the explanation? Or am I wasting my time making this video? And again, I'd done all this work. I had filmed all these videos. I had put together all this observational data that says that erosion is happening really quickly. And this seems to explain away the problem. Here is more pictures of marine terraces. Erosion cuts in, the continent lifts up, pushes the coast back, and then erosion cuts in again. And it forms kind of what looks like steps. and that keeps the coastline at its current position over time. So even if erosion cuts in at 3 feet per year, eventually the continent uplifts and the coast just moves right back there. And it hasn't happened, like there's no continental uplift. It hasn't happened in a long time for us because we still have to move these lighthouses back and back and back. But eventually, maybe a million years from now, the continent uplifts and pushes the ocean all the way back to account, and the whole thing starts over. And we get Cape Cod again. I don't know, maybe Cape Cod pops out of the ocean again because the continent uplifts and the land that has been buried underwater pushes the ocean back, and we get a Cape Cod again in a few million years. Maybe that explains the whole thing. Here are marine terraces in real life. Actual photograph, first marine terrace there, second marine terrace a little bit further back, and third marine terrace there. Is this water comes in, it cuts in and erodes, and then the continent rises up, and the new land pushes the ocean all the way back. And there's the ocean bay. You can see a little bit of the ocean water all the way on the right. Here is a great picture of marine terraces. You basically have this coastline. Erosion cuts all the way in. The coastline is then moved back because the continent rises up and pushes the ocean back. And here is where we finally come to my final point, 50 minutes into this video. Thank you for making it this far with me. But this explanation also does not work. And this is, again, credit to Monty Fleming for finding this and for publishing his book on why he does not believe that the world is very, very, very old. It might look like it's very, very, very old in a lot of ways, but when you dive into the full story and read, and you do enough research, you come up with timestamps on how old things can be. So why doesn't this work? Why can't the continent just keep lifting up, and pushing the ocean back, pushing the ocean back? And we have also evidence of this process happening for a decent amount of time. It explains hundreds of thousands of years, maybe a few million years of erosion, but it does not explain how the North America is 200 million years old. Here is why. In order for 200 million years of erosion to be accounted for, you would need 171 cycles of uplift. Okay, 171 cycles of uplift. You would need 5,000 meters total of uplift since the Eocene. Okay, which is Eocene is a particular era in the history of geological time in the conventional paradigm. The Eocene is also a rock layer that is supposed to correspond with that period of time. So you need 5,000 meters of the continent lifting up since that period where the North America is still in existence, right? So 5,000 meters total of continuous uplift. And so that basically, and Monty did this calculation, basically the amount of continental uplift you need the continent to rise up so many times that you're basically putting the North America continent in the atmosphere, right, where satellites are. That's the amount of 5,000 meters is really, really high up in the sky. And the continent is not going to continuously lift up all the way to that point. So the rate of erosion basically, here's the point. The rate of erosion is still too fast to account for this because the rate of erosion is so quick that you would need so many cycles of the continent uplifting that you're pushing the continent up into the atmosphere. And that, of course, is ridiculous. It's astronomical. And this works somewhat well as an explanation on the West Coast. So I should have switched a picture here before anyone points this out. This is a picture of the West Coast. I'm talking more about the East Coast. I'm still talking about East Coast. And the erosion in the East Coast is so fast that it continuously pushes the continent higher and higher and higher that it makes it astronomically high. And on top of that, the observed rate of uplift today, because the continent is still uplifting gradually today, the rate is too fast in the conventional model. So the rate of uplift is fast today to account for this. And not only that, but you would need so many cycles of uplift that the continent ends up being so high up, it's at satellite height. And so, of course, I don't think that has happened. I think it is more reasonable to say that the continent has not been separated from Pangea for 200 million years, slowly eroding away, or quickly eroding away, rather. Instead, it broke away. It's been moving away from other continents at a much faster rate. And the catastrophe that happened 4,000 years ago in the flood caused that rapid erosion to bring us to where we're at today. So again, this is us doing our research. Okay, we did our homework. Monty Fleming did his homework, and this is what we're coming up with. So at first glance, it looks like these explanations of accretion and continental uplift, it looks like they can explain the problem very well. But when you dive into it and you say, what would this look like over hundreds of millions of years? It all falls apart. So I've said this before, but I don't think our continents, I don't think our world was built or designed to last hundreds of millions of years. And this is not a it's not just saying that the world is not hundreds of millions of years old. It's also saying this world cannot last hundreds of millions of years from now. Everything is coming to an end soon. I made that point in my original video series that we're standing on land that is not infinite. It's not eternal. It's not going to stay here forever. Its processes are at work every single day that are breaking it down and destroying it, basically. And that puts a timestamp on this continent. And this timestamp might say millions of years from now. We might have 5 million of years to work with. But again, there is a timestamp on the world. There's an expiration date. And before that happens, obviously, we know how things are going to end. It's told to us in scripture that God will make a new heaven and a new earth. And so as this world winds downwards and erodes away, we can remind ourselves that this is not how the world ends. The world is not going to end in 5 million years because of erosion just cutting it away and turning us into Waterworld, right? That 90s movie with Kevin Costner, where it's not going to turn into that. Jesus is coming. He's coming again soon. And the world shows evidence of that because it's not going to be here for all time. So some concluding remarks there. This explains my erosion series. I apologize for the mess ups on the slides, but hopefully the information is being conveyed to you. Check out Monty Fleming's work. He was on Let's Talk Creation podcast, and he also did a lecture as well that I can link below. And thanks for making it with me this far. Hopefully that puts my coastal erosion series in perspective, and you can go see those videos if you haven't yet, and you can just see videos of everything that I showed you at the beginning of this seminar. And thanks so much for joining me. This is Jake Ramgren with the Creation Reformation YouTube channel. Thanks so much for watching, and I'll see you on our next topic.